In this video, we'll talk about integration. So essentially, we can think about integration as the opposite of differentiation. So let's say we have a derivative dy dx. If we integrate it with respect to dx, we'll get the y function, the original y function itself. So in this question particularly, we have a double derivative. The same, if we integrate it with respect to dx, we'll get the dy dx, the derivative. But if we integrate it for one more time with respect to dx, then we'll get the y function itself. So this is what exactly we'll be doing. So first, we'll just integrate our double derivative, and the outcome will be our dy dx. So the first step we'll do is that we will divide the power plus 1. The reason for this is that in differentiation, we multiply the power, but notice that the power we have here is already minus 1 in differentiation. So right now we're plussing 1 back, so we can get the original power. And the next step is that we will divide -3, because in differentiation, because of chain rule, we also multiply the derivative of the bracket. So the coefficient is -3, so we're dividing it right now. And here comes our bracket. The same in the power will plus 1 for the same reason. And the most important thing in integration is that we plus c, we plus a constant, because in differentiation, the constant will be changed to 0. We don't know if there is a constant that has been differentiated to 0. So we're plussing a c just in case. So we'll go ahead and simplify this expression. This will be 3/2 times -1/3. The 3 and 3 cancel out. So we're left with -1/2, 2 minus 3x to the power of 2/3 plus c. Next step is that we'll calculate c. So the question told us that at x equals -2, the gradient is -6. So we know that the outcome of a derivative is the gradient. So this expression at x equals -2, it will give us -6. So we'll just plug in the -2 into our x. This entire thing equals -2. -2 plus c equals -6. So c equals -4. And we'll put our c back to our original expression. So dy dx equals -1/2, 2 minus 3x to the power of 2/3 minus 4. Now we have a derivative, and we'll integrate it one more time. So we'll integrate -1/2, 2 minus 3x to the power of 2/3 minus 4 with respect to dx. So the coefficient of this bracket will remain the same. Then the same, we will divide our power plus 1, and we'll divide our coefficient of x. Here comes a bracket and the power plus 1. And the 4 here, we can think of 4 as 4x to the power of 0. This equals 4. And we'll plus 1 in our power, so it will become 4x to the power of 1 or 4x. And the same will plus c. We'll go ahead and simplify this. Negative 1/2 remains the same. This is 3 over 5, and this is negative 1/3. The 3 and 3 cancel out. The negative cancel out. So we are left with 1 over 10, 2 minus 3x to the power of 5 over 3 minus 4x plus c. And the question told us that at x equals negative 2, the y coordinate is 10.2. So we'll go ahead and solve for c. We'll plug negative 2 into our x. This entire thing equals 10.2. And our power is getting a bit complicated, so feel free to use your calculator if you need. So this entire thing is 3.2, then minus 4 times negative 2, this is plus 8, plus c equals 10.2, so c equals negative 1. So our final step is to put c back to our original y function. So our final answer is y equals 1 over 10, 2 minus 3x to the power of 5 over 3 minus 4x minus 1. This is a 10-mark question, so expect it to be complicated. So we will integrate from point A to point B, but we don't know yet the function of the straight line, so that's what we have to do first. And the plan for this question is that we'll integrate this line function from A to B. Then we'll minus the integral of 3 plus 2x minus x squared dx from A to C. So we can minus this area. So we'll find the line function first. So the question told us that the x coordinates of point A is 1.5. So this point is 1.5 and we don't know the y. And we can know the y by plugging 1.5 into our quadratic function. This will give us the y. So after doing that, we get that y equals 15 over 4. And when we look at the line function, y equals mx plus c, the m here is the gradient. And we can know the gradient by differentiating our quadratic function at point A. So we know the gradient. So we'll do it first. dy dx 3 plus 2x minus x squared. Differentiating 3 gives us 0, so we don't write it. Differentiating 2x gives us 2. Differentiating minus x squared gives us minus 2x. So we'll plug in 1.5 into our x. So 2 minus 2 times 1.5. This equals minus 1. So right now we can use our straight line formula. y minus y0 equals n times x minus x0. Our y0 can come from here, our coordinates. 15/4 equals m the gradient with calculator minus x minus our y0 is 1.5. We'll write it as 3/2. Then after simplifying this, we will get y equals negative x plus 21/4. Then using this line function, we can know the coordinates of B. So at B, it is some x coordinate and the y coordinate is 0. So when y equals 0, we'll solve for x, and the x equals 21/4. So we can put all these numbers and the function into our integrals. Our straight line function is negative x plus 21/4. Our b, the x coordinate is 21/4. Our a is 1.5. Our c right here, we need to factorize the quadratic function to get c. And after factorizing that, we get x plus 1 times minus x plus 3. Then the second factor here told us that 1 root is x equals 3. So c equals, the x coordinate of c is 3. And the RA is 1.5. So we'll work out this entire integral. So right now we have two integrals and we'll calculate them separately. So our first integral, minus x plus 21/4 with respect to dx, from 1.5 to 21/4. Our power here of x is 1, so we'll divide 1 plus 1. And the minus x remains the same. And the part 1 will plus 1 here. Then plus the integral of a constant. And the shortcut with constant is that we simply add an x. So this becomes 21/4 x. And we will evaluate it from 1.5 or 3/2 to 21/4. After simplifying this, we get 1/2, we get negative 1/2 x squared plus 21/4 x from 3/2 to 21/4. So right now we'll evaluate it. So 21/4 into our first x, square it, then multiply with negative 1/2, it is minus 441/32. Then plus 21/4 into our second x. 21/4 times 21/4, it is 441/16. Then this entire thing minus 3/2 into our first x, square it, then times negative 1/2, this is negative 9/8, plus 3/2 into our second x, 21/4 multiplied with 3/2, this is 63/8. So you might need your calculator, and this entire thing is 225/32. So we can put this here. Then we'll do our second integral. We will calculate from 1.5 to 3. the integral of 3 plus 2x minus x squared with respect to the x. Then the integral of a constant we multiply with x. 3x plus 1 over, we divide the power plus 1. 1 plus 1, 2x, then the power plus 1. Then we minus the power, then we minus 1 over the power plus 1, x 2 plus 1. Then we'll evaluate it from 3 over 2 to 3. So we'll simplify the entire thing. This will be 1/2 times 2, or they cancel out. So we're left with x squared, then minus 1/3 x cubed from 3 over 2 to 3. And to calculate it, we first put 3 into our x. 3 times 3, it is 9. 3 squared, it is also 9. Then 1/3 times 3 cubed, it is also 9. The entire thing minus 3 over 2 times 3, this is 9 over 2. 3 over 2 squared, this is 9 over 4. Then minus 1/2 times 3 over 2 cubed, this is 9 over 8. And our final answer is 27 over 8. So our first integral is 225 over 32. It will minus 27 over 8. And the final answer is 117 over 32. This is our final answer.